So let this be theta. This is a fixed now, it will not move. Let's start one by one. This will be mg sine theta. No. What can be spring? Elongated, compressed. So what do you suggest here?
Elongated.
Will be elongated. It must be elongated. It must be elongated. Kx1, I'll write it. Or x2, anything, because two springs are there. No, let me call kx1. The system is in equilibrium is telling pulleys are light, the thread is light in nature, the springs are light, and the block B, C are connected to axles of respective pulley by the acceleration of block. So kx1, I'll write it. So here the same spring force should act here. The same spring force is what here to show it. So here kx1, this will be kx1. Then here, this is mg. So what all the other forces that are acting, that become internal. The pulley and this link no will become internal. So there's a condition. Okay, now with this, can you say anything about 2kx1 equal to mg? No. So from
sin theta 1 by
2kx1 minus mg equal to 0. So kx1 equal to mg by 2. This is for pulley P1, I'll write it. Pulley P19, P2. So here what happened? At pulley P19, block B. Okay, got it now? So from there, I searched it, I got this much here. Okay, keep it here. Now for block A, kx1 minus mg sine theta equal to 0. This is for block A. Kx1 equal to how much? Mg by 2 from the above equation. So theta I'm getting
30 degrees.
30 degrees. Okay, now fine. Let's come for this. So kx1. So here what are this will be mg. So the same spring force should act here again. Kx1 and this will be kx1. So here I'm not sure anything what is the spring force. So let it be, it didn't say anything. The springs are light and the block B and C are connected. It didn't say anything about the springs. Are they same or different? So what shall we do here? Anybody? It didn't say anything. There's no information about the spring. The pulleys are light and friction. The thread is light and initial. The springs are light and the block. So the springs are telling the springs are light means so the same identical condition. So let me assume K only.
Sir, can you repeat why, sir?
The springs are light and the block B ends are connected to axles of the respective pulleys by rigid links. The springs is telling the springs are light, so it assumed same spring constant. The question itself, he didn't say anything. Let me assume some value, both let it be same. Okay, fine. So don't blame me now. So let it be some elongation kx2. Okay, fine. I'm just assuming it to be k. We will see any difference will it make. What about kx2 from the diagram? Kx2 should be equal to 2kx1 plus mg. No, this is for what? Pulley P2 and block C. So kx2 is equal to how much? Kx1 is equal to mg by 2, or 2kx1 is mg. So this will be mg. This is 2 mg. So don't blame me. I'm just assuming some value of k. This one. So let it be. So this is the initial part. Okay, let's come for the thread is cut at point P. Where is the point P? The point P, I'm bringing it here. There's a point P and there's a point S where I'm going to cut the spring. Okay, if I cut the string at point P, What conditions will arise? What will happen to this particular string? That will become loose, no? The string will become loose. What will happen to spring force here? There's a really troublesome for students. Sir, you only said sudden change in spring force possible, but this particular say like the spring what happened got elongated, no? So where is the support for him? The other end is support here, no? The support is there. This will be, if this is cut, what happened? The string will become loose till here it's connected. So what happened to spring? Spring what happened? The spring force will vanish. Here what happened? This spring force will vanish here.
Sir, can you repeat it?
So now you look at this particular spring, no? So what actually happens here is, I think I'll help you with a diagram. If this is a thing, it is being elongated, and I'll connect this spring to another wall in this way. Let's assume this one here, this one. So now what is the state of spring? So let it be elongated. The same similar thing to make you understand I'm bringing. Now if I cut this particular string, tell me what will happen to this particular thing. The spring what happen, all this will suddenly the spring force will vanish. Because why the spring force is there? Because of this tension. Or this you'll not understand the block. I'll
Sir, it will come back to its natural length.
Yeah, that one. So what I mean to say is spring force will vanish. Okay, if it is like this, you have string and a spring like this. Now if I cut this particular string, now what will happen to it's being elongated? Why it is elongated? Because tension, I'm saying the string is taut. So therefore the spring force will act like this. So let's assume if I cut it, tell me what will happen to the spring. So what is the state of this? This particular string will be tell me what should happen to spring, anybody? The string is permitted to attain its natural length, no? All of a sudden what happens? The spring force will vanish here because there is no force to maintain that elongation. Because earlier what happened? How that elongation is maintained? Because here there was one more force is acting. What is that one more force? The reaction by the wall. So how that particular spring is in equilibrium? Because the tension T and this R. So now what will happen to spring? Spring will attain its natural length. This is earlier elongation.
Sir, the spring is attaining its natural length only because the string connected to the spring is being cut, right?
Yeah, that one. Because there is no supportive force for the spring to retain that particular length, the particular elongation.
Okay, sir.
I think this idea is very important, where most of the books what happen are missing it. That's why I just picked up from this particular thing. So let's later on we'll apply this to various concepts. So here I think I'm giving diagram like this. Fine. So what is this string now? So there's no elongation or compression. Is it similar thing happens for this particular spring? As the spring will attain natural length. So therefore I'll call this a spring P, A, B, C, S. All the symbols are used, no? P is there, P1, P2. Spring S1 I'll call it, or say like a S1. So what is the condition I should write? When the string at point P is cut, so what will happen to the spring force in spring S1 will vanish. Then what will happen to the block A? It will only experience its weight, no? Mg sin theta. So then what is the acceleration of block A?
G/2.
It should be equal to G sin theta, just acceleration down the incline. See, all these questions are not something within 2 minutes here to solve. Of course, they need time. All these are learning questions, not something for to test a student, just for learning purpose here. So first case, I'm starting the first case here. Thread is cut just after thread is cut at point P. What will happen to spring? Spring force will vanish. The spring S1 will spring force in spring S1 will vanish. Vanish in the sense attains natural length. Okay, fine. So what happened to the block A now? What is the only force acting on the block A? G. What is the mg sin theta by m? So what is the acceleration of block A now? So what shall we write? Acceleration of block A should be mg sin theta by m. G sin theta. So this should be g by 2. What is the direction? Down the incline. Is that okay? Arrow, look at this. No. The string is passing over a pulley, no? The string is passing over a pulley. This particular string is passing over a pulley. Why it is connected to spring S? Look at the diagram. This particular string is passing over a pulley and the spring is connected to the pulley P2. What should happen to block B and C?
Sir, since there is no support for B, it will go down, sir.
With G, sir.
What happened to B and C?
C will remain at.
Sir, C is a test.
C will remain as it is.
Acceleration of block B, anything, anybody?
Sir, it will go with acceleration G downwards.
Equal to
G,
G
sir.
downward, no?
Yes.
Because acceleration of B is what? mg by m. So it should be G downward. What about similarly C?
0.
Earlier, what happened? So look at this earlier. Kx2 was balancing to Kx1 plus mg. Now the spring force Kx1 got vanished, no? So what are the forces that will be acting on the block C now? Block C, the pulley and block C you take together. So what force I have to show it? I think I have to draw a diagram. Huh? Nobody will understand if I just speak it.
Sir, will it accelerate upwards, sir?
Yeah, that's what I'm telling. So this is the spring. Okay, now here that spring force will remain as it is, no? So this is the string. Okay, all of you try to see the diagram. I'm some way I'm trying to help you. So what happened? The string has become loose, no? So this will be what are the only forces acting on this system now? 2kx2 minus mg. So together with the pulley P2, the block what happened will experience a force 2kx2 minus mg. So what is the acceleration of C? Should be equal to 2kx2 minus mg by m. What is the kx2 value is how much?
Sir, 2kx2 is 2mg, sir.
Okay, this one. I think kx2, sorry. Kx2 value is how much? 2 mg. So this should be equal to g upward. So therefore acceleration of C will be Fine. So these are our answers. Huh?
Sir,
Ah.
sir, just a small doubt, sir. In the right side, starting supportive diagram for spring, sir.
Here,
Can
ma.
you cut
Here. Huh? So the string it is passing over a pulley and the spring is connected to pulley.
that spring?
That spring is connected to pulley
Yes, sir.
here. Not connected to string. It will be connected to pulley like this.
Yes, sir. In that supportive diagram for the spring S1, sir, there will be a normal reaction by the wall also, right, sir?
No, that will become everything internal. No, it's a rigid link that will become internal. All that forces acting on the pulley and block, you take one system. So what all force that acting between the pulley and the block will become internal. We need not to bother. That everything will become equal and opposite. Am I right?
Yes, sir.
I just made problems simple. Huh? So if you want, you can show forces, but that will become internal. So need not to bother, no? Because he's telling this is not a string, rigid link. Am I right?
Yes, sir.
So the forces acting in this will be equal and opposite. Finish all. I'm making pulley block as one system. So what force acting now in this rod, no, that will become internal force for the pulley for P2, this one here. So what is this equation I wrote for the total? This is for both for pulley P2 and block. So this is what will happen even for acceleration of okay. Is that okay? I think I'm helping you this much. At least okay now. Fine.
Sir, but what about in the spring S1? What about the normal reaction by the wall, sir, in that above diagram?
Which one? Here, huh? This particular thing. Huh?
Yes, sir. You cut the string and you drew a diagram down.
Yeah, this normal reaction. Huh?
Down, sir. Down of that diagram.
I don't know, down of the
Sir, you
diagram.
drew a diagram.
Yeah. This one here. Huh?
Yes, sir. That normal reaction by
Okay.
the wall.
So some because of some why normal reaction? No, string is light. Finish. Oh no, nothing will be there.
Sir, for the spring.
For the spring also, nothing will be there because no spring force, because no force is acting. This R also will vanish. This R will vanish.
Okay, sir.
Yeah. Okay, now I think we have completed half part of the problem. Huh? And now the spring S is cut. Now, is it justified to write K only or can I take any value? Because I think I assumed it. This what we assumed it. I'll write it clearly. It didn't give. Shall I assume some K dash? Will answer will be same? I think students really should answer this.
Yes, sir.
Because it doesn't matter, no. So therefore, I assumed it. So I think you should not blame me, huh? Because initially somewhere telling sir to get answer you are writing. No, if I write 2K or K dash, it doesn't matter. Am I right? Even if I write K dash also, I'll get same answer. So I just assume
Sir,
that
only sir.
at S what happened, the spring constant didn't give, intentionally didn't give. So we can assume any value, we can continue, we'll get the same answer. No, the spring S is cut. I'm going to cut the spring itself.
Sir, is S on the spring or is it on the string connected to the spring, sir?
S is the point on a spring, no?
Okay. Okay, sir.
Okay, I'll get the diagram. So there's a block. There's a pulley. If you want, you can call them as rod. These are some rigid link is telling. So this particular thing will be rod. Okay, this will be a rod. Hmm? Okay, there's a diagram. I'm continuing here. This is theta, what we earlier assumed it. Okay. Now what I'm going to do is like this particular spring, I'm going to cut it. Tell me what will happen. I'll just show like this, so that it'll be easy for you. So it justified that the spring is being cut. Okay, now try to analyze the problem. These are the pulleys. It's a good problem for really, like I would have been felt happy if students on their own, they would have thought such challenging problems. But nowadays students, they don't have patience. The moment they see question, they want answer. So that learning ability of students got decreased like anything. You should blame the education system in India. The competitive exam, you have to blame that one. Because the overall things happen, they don't permit you to really learn. You can blame even teacher also. Because yesterday I gave how many, some 30 questions and I asked you to come on, give the answers for this. So there'll be wrong thing, no? When spring S is cut. So the second part of the problem, when spring S is cut. Yeah, can get into the problem now. What will happen to spring force? Directly spring force will vanish, finish over. The spring force, the kx, what was the spring force that was acting here, no? kx2 was acting, no? So the spring force kx2 vanishes. So here I'll write it, no spring force. Now what will happen to the other part? What will happen to this spring? What will happen to this tension? So that the weight will act, the weight mg will be acting. Here this weight mg will be acting as usual, and this mg sine theta. Yes, anybody answers? So what happened to this spring force? Spring force kx2 vanishes, or kx2 is equal to 0. Now this one, anybody? What shall I do with this particular string? This was the point P, no? Yeah, I'm telling this one. What will happen to any impact on this and the spring force?
Sir, there is no impact on the other spring, sir.
Sir, thread will become loose.
Just after the spring is cut, there won't be any impact, sir, but eventually the thread will become loose.
So this spring force, nothing will happen, no?
No.
Because so the spring force as usual, I'll show it. kx1. So here what force? kx1. This will be kx1. No, this much will be there. Huh? So now there is no change in the force acting on the block A. Am I right? So net force on the block A is 0, no? So shall we write first equation? Now what about the force acting on the block B? Earlier to the pulley and the block B, you treat as one system. This rod you need not to, the forces acting in the rod will become internal. Okay, all of you? I'm making things clear. So what is the net force on the pulley P1 and block B? Will remain same as it is, no change. So therefore acceleration of pulley P1, acceleration of block B, 0. I'm making things clear like this. Let's come for block C. Earlier what happened, the KX2 was acting, KX2 was balancing KX1 and mg, no? Now that balancing force KX2 is not there. So what is the net force on the pulley and the block C? Pulley P2 and block C is downward, no? And the force acting in the rod will become internal. So here, if I show one more diagram, spring force, there's no anything called like a spring here. So this is what I'm showing. At least all of you looking at this diagram, you should able to understand what I wanted to explain here. Rather than speaking blindly, no, I'm giving enough of proof for you. Pulley is light. So what is this everything will become one system, no? And what is this? This is a rod, it should not be a string. If the string, there's a big problem will arise. This must be a light rod. Now, what is the net force acting on the pulley P2 and the block C? Spring force and the weight. So therefore, what is the acceleration? AC should be equal to 2k x1 plus mg by m. What is kx1 value? Should be equal to mg by 2, as we know already. Total acceleration of block C should be equal to how much finally?
2G, sir.
2g, it should be downward. So what are our answers? Acceleration of pulley P2 or this one? Both are same.
Sir?
Ah.
So the acceleration of block C is due to the loss of spring force only, no, sir?
Yes, yeah.
Okay, sir.
Sir, what happens if it's not a rod and if it's a string, sir? What problem?
Then tensions what happen, impulse will come, a lot of complications will come. Then we can't conclude the problem.
So what
Okay.
did you say, sir?
Impulse, if you don't know impulse, so I can't explain impulse one chapter itself.
Sir, what was the question?
Whose question? You don't bother. You don't bother. Because if the string, what happen, the impulse impact will be there. Again, it'll be very complicated. Huh? That's why what happen is showing that is nullifying things. Huh?
Okay, sir.
That's okay. This is what I think. Okay, yeah. The second part. Okay, it's visible. Completed this. One more last one more within 10 minutes. Huh? It's a very small one. Where we'll wind up this. Huh? Or shall I continue?